Hello and welcome to the CloudSwyft webinar on Microsoft Azure technology skills in digital mental health. Today, we'll be hearing from experts in the field of digital mental health, Dr. Ben Hadyan, Chief Experience Officer at AEST Australia, and Dr. Naim Rastgoo, Head of R&D, Lead of Artificial Intelligence Scientists at AI Health. We will discover interesting things on the webinar today on mental health trend in Australia, its impact, the effects of artificial intelligence on mental health, machine cognitive services, real-world use of Azure AI, AR opportunities in healthcare and mental health, and the role of Microsoft Azure and machine learning solutions in all of this. During the webinar, you may have questions you will want to ask Dr. Ben or Dr. Naim. Let us know who the question is for. Feel free to send them through the Q&A section marked as a chat button with a question mark in the upper right-hand corner of your screens. Don't forget to enter your name as shown on the image to your right. The webinar will begin shortly. We'll begin at the hour on the dot. Please stand by. Let us now welcome our first speaker for today, Dr. Ben Hadyan. Dr. Ben, I'll pass it on to you.
Hello, everyone. Who would have thought that we going to have a full attention for the mental health, and especially digital mental health? And one of there's too many negative things with COVID, but one of the positive things I can see is the attention we receive for the mental health services and also for the mental health and well-being for individuals. So today I'm going to represent the digital mental health in general and in specific for Azure. My name is Dr. Ben Hadyan. I'm the Chief Experience Officer for AI Health, and I'm also a Deakin University Fellow and also a mental health consultant for the National Center for Mental Health Promotion of Saudi Arabia. And my LinkedIn is Ben Hadyan, and I'm probably the only one with this name. And if you find another name with this name, let me know, because he probably going to be someone we don't know. Today, I'm going to take you a journey about starting from AI health and going through the mental health of Australia, the digital mental health, the good and bad things about mental health, and then we'll talk about the human aspect in digital mental health. From engagement to behavior, then an overview of all the Azure features and services, and one of them is the cognitive services. And here where I can lead you to Dr. Naim, who is going to talk about the Azure cognitive services in detail. So AI Health started in 2016, and it's part of a bigger organization called AI Australia. Was established in 2016. Mainly we were focusing on using the advances in technology to improve the health services sector. We are also a Microsoft Gold partner, and also we are HL7 member. One of our biggest clients is New South Wales Health Department. As we all know that mental health is the main aspect of doing stuff. If you feel stressed, you won't be able to do a lot of stuff or perform. So in Australia, we have 1 in every 5 people living in Australia experience mental health issues. 65% of them don't access their mental health services, the traditional one. Majority because of stigma and financial situation and location for both service provider and patient. The majority of the mental health disorders we have here, we have anxiety, just take a big chunk of the statistics. And we have a 5% of substance abuse, majorly on for the alcohol. And because of this mental issue, we have it can cause up to $5.9 billion loss in productivity each year, and we're expecting to increase by 40 to 14% and 45% in cost and 14% in cases. This statistics was way before coronavirus, and I'm expecting this kind of will probably double after the coronavirus or post COVID-19. So what is digital mental health? I describe digital mental health as just an additional layer on top of the traditional mental health services to improve accessibility, efficiency, effectiveness, and usability. And are divided into 5 services. Promotion, which is usually on how to educate, improve mental health literacy for the population. Prevention is to prevent prevent causing mental health disorder. Like if we have people at risk, we can prevent them from having a chronic anxiety or depression. And treatment can be a face-to-face or a video conference treatment. Crisis is to when a crisis happens, like what we had early this year in Australia, the bushfire, and now what we have, COVID-19 is considered as a crisis. Then after that, what happened after you recovered, which is a recovery plan. All these services are covered or supported by different types of advances in technology, and most of them, or all of them, are based in AI these days. One of the advances they use in virtual reality, the example, is replicating what happened to, for example, people with PTSD. There's an app called Virtual Iraq that used for a veteran who came from Iraq, just to replicate the event that happened to them, so they can probably pass the anxiety of it or the episode. And usually all these apps and services targeting depression, anxiety, bipolar, OCD, and addiction. The good things about digital mental health is to improve efficiency and reduce costs, which is overcome the overcome the obstacles we talked about earlier. And it can be developed and targeted to many people, to different ages in one hobby campaign. And also it can be accessed anywhere and anytime. The issue is with digital mental health, and I see it as any digital services online that have exactly the same thing. Where the data is stored, is it secure? Is my data private? Is it high privacy? Who's going to maintain the application? Who's going to maintain the platform, and who's going to fund it? If there is no fund, you can't sustain it. For Australia, we started early in improving the mental health, so digital mental health. We started from 1970 until now, and through the time, multiple NGOs and SOs started to establish, based on what I see, this development started from data, dividing the data into two types of data: data that for consumers and data for researchers and government. And now we have a digital gateway and we have a sub-care model. For example, Head-to-Health it's a public gateway for digital mental health that has all the apps and services, usually checked before published. And we have a 412 that between chat, programs, forums, and websites. For example, Beyond Blue, which is one of the biggest NGOs for mental health, and here they have up to 45 websites targeting different mental issues and social issues. The negative impact of the internet or the social media on mental health. There's a lot of studies saying the more people spend on social media, the more mental disorder or mental distress they will have or experience. One of the issues that we found between all these, especially the younger generation, like the bullying, the rumors, the physical threat, the making fun at their pictures and all this stuff. All these aspects can create stress and probably anxiety. So when it comes to dividing or building a digital mental health, there is a small aspect that you can, or features or factors that you can have it. And the minimum things you can have is the feedback. The feedback is very important. You can divide the feedback into three types of feedback. There's automated feedback. You can use an AI in it. You can use clinical feedback that it comes from the doctors or service provider, and there's this semi-automated or tailored feedback that you can tailor it. It comes from social or clinic. Second one is the reminder. It's like if you have a tailored reminder with a really nice messages, you're probably going to improve the engagement. Mood tracker and progress monitoring, that it shows this is for the patient, it shows the mood throughout the journey of their recovery or treatment. That will enhance them to also more engage in the application. Clinical support. There's a lot of studies shows that if there is no clinical support in the app, there's a high likely for a lot of patients not to engage in the app. And also the social network support that comes from it. And the ideal app will be if you combine two of this aspect, clinical support and social network support at the same time. Gamification, it's everyone using it. Instagram use it, Facebook use it. It is to enhance or to remember the people is to use how to use the app more and more is part of the psychology. And the last one is the UX and UI. The easy way to use the app, the more engaged for the consumers to use it. For example, like bipolar people, there's a study was saying if they are in their depressed mood, they find that they would like to have a high secure and login, and if they are in the mimic one or the manic one, they just want to have an easy access, no password. For the provider, this is my study when I examine the factors between clinician and patient. One of the most important things is the clinical expertise. Like if the doctor never heard of the app, never seen it, he or she will probably not going to use it. So and also if the clinician work in a clinic that use a lot of technology, he will probably be encouraged to use more technology by himself. Second one is trust. A trust can be where the data is used. Do I trust this app? Do I trust the one who developed this app? Where the data is stored? Then how much is going to cost me? How much is going to cost the patient? Is it for free? Is it funded by the government? Or funded by in-kind contribution from a businessman, let's say? If the app is covered by the health insurance, public or private? All these aspects are actually enhances for clinicians to use the app. And I always say, before writing an AI, you need to understand human behavior. If you don't understand human behavior, you'll just copy what everyone's doing and you will not be elite in what you're doing. For example, like from the 5 personality traits, narcissism, which is basically how you feel, are you worried, and all the mood status, frustration, jealousy, and loneliness. And especially now, we've been COVID, most of us have been isolated, they feel lonely. But there's a lot of studies shows that this kind of personality impact on the engagement as well. So if it's too high, it will impact on the usefulness of the app. They will perceive it as not useful. If they're really anxious, if they're really worried, if they're really angry, they will see it as not good. But they will engage in more social interaction, like chat. So for example, if you want to create an app targeting anxiety, you make it simple so you don't have to overthink it. And at the same time, you introduce the chatbot or like a normal chat. For Azure, we use Azure in different services and features. For example, as I said, an easy UX for a patient, it will engage them more with the app. We use B2C, Azure B2C, to take all the authentication responsibility and boost the security aspect of it and allow external users to use our internal Microsoft products, like you know, the CRM or the cognitive services. Dr. Naim is going to talk about it later. And also, Azure provide us with the fast healthcare resources that are provided by HL7 that will ease the communication between us and other service provider, either government or private. And at the same time, we don't have to worry about how we can develop our own messages services that will match the fair requirement. So the Azure will do it for us and engage. At the same time, we store or deploy all our apps from Android, iOS, or PWA stuff on Azure App Services. For example, here's a quick diagram of how we can use. This is a default one from Microsoft website, and how Azure is actually can handle all this stuff, like storage blob is like where we store some of the graphics and multimedia files, and how we can use the app services to access also the back-end services, for example, the Azure SQL database. And here is like, it shows you how Azure can connect a lot of external service provider or tools or IoT, and make it present in fair API, and we can use all the machine learning and artificial intelligence and analytics that Azure can provide us with the Microsoft product we have, for example, Microsoft Team or Dynamics 365, Tasks, Flow, Power Apps, and all the others. So there are two types of AI in mental health. There's the conversation type, and there's the pattern recognition. So, for example, the conversational interfaces, we have two types. There's the chatbot and the voice assistant. We did, just for the curiosity, we did a test, and we test all these voice assistants, like, for example, Google, Siri, and Cortana. And we say, I'm feeling suicidal. And all of them show us, we have to call Lifeline Australia, which is really good. I see it as it direct. It's still early. It doesn't have like an intelligent conversation how to break it from the suicidal thoughts, but at least it will show direct. And it will be really good for the international audience if they can show us what do they receive in their country when they say, I'm feeling suicidal. It would be good if you can post it also in the chat with the country you're from. For the chatbot, for example, you can use the language we can Louis in different apps. Like you can use the B2C to access all the app services and also the Azure Bat services. And you can use the language understanding. It's a cognitive Azure cognitive services, and also you can use the structured data to make the chatbot direct to the final destination that you would like to get. For example, if someone put something like, I would like to lose weight, you can design the chatbot to, call a goal setting approach, divide them into steps, and so on. For the behavior pattern recognition, it's to analyze what everyone's doing, from text to voice to facial expression to language, and what we're using at the moment. Like most of the data that is being used by other companies, big companies like Facebook, Instagram, Twitter, all this input are now used to direct them for either for products or services, opinion or movement. More like as much as this data is useful, it is sometimes harmful because it might increase your anxiety, it might increase your depression and things like that. We can use this app that is now used for different products, for example, marketing or selling a product. We can use this data to flip it, and we can train it again for mental health approaches. For example, like the Azure Cognitive Services, it has 5 different services: decisions that will help with decisions, and web search that will help with the web search, and for the speech one, the speech to text, text to speech, speech translation, and so on, languages, different language, and the vision one, that where Dr. Naim is going to talk in detail. My recommendation when you choose the app is, also from Black Dog Institute, is do not ever just download the app because it's app rating. Sometimes it does not promote well. The app rating is good, but the function is not. Find out who developed this app. Is it just a bunch of people who just doesn't have experience and just jump into the trend wagon of digital mental health, or trying to make an app for money? Just see who is behind it. And also read the privacy and policy, because there will be a lot of fraud and security threat in most of the apps. Most of the people who I see when they look for mental health app, there is how can I say it? The hackers or frauders, they can use hope to get what they want. So for example, let's say someone is just looking for something to help him overcome all this depression symptoms, and in a weak point, you download this app, and the one who's behind this app is just uses hope to get more, money, data, private information, and use it against him. And the most important thing is just to look if this app is based on evidence and clinical trials, if there's or just someone just developed it and just put it in an app store. So thank you so much for listening, and I will hand you to Dr. Naim.
Can you see my screen now? I think that there is a problem.
Yes, you can, Dr. Naim. You're coming in clear.
So just want to know that do I need to start from first, because I'm not sure that audience hear my sound from the first.
Yes, we can. If you could start again, Dr. Naim, that would be perfect.
Okay, that's fine.
Thank you.
Thank you, Dr. Ben. Hello, everyone. I'm Dr. Naim Rastgoo, lead of AI scientist and head of R&D at AI Health. My expertise in AI, AI, machine learning, deep learning, computer vision, and signal processing. I have been involved in several multidisciplinary projects that we use wearable sensors like as electrocardiogram, ECG, brainwave, electrodermal activity, EDA to detect cognitive load and different emotions. Today I'm going to talk about the concept behind emotion and how we can recognize emotion based on the machine learning and deep learning technique. And at the end, I will talk about Azure Emotion Recognition API that is integrated in our mental health product to monitor user mental health. So the first question that comes in our mind is that what is emotion? Emotion is defined as a class of feelings that are differentiated by their specific kinds of subjective experiences. This is important to know that emotion plays a key role in individual and social life. For example, our decisions in our daily life are based on whether we are happy, angry, sad, bored, or frustrated. Also, emotion incite us to do some activities and hobbies. Therefore, emotions are an inevitable part of human life and control human decisions and activities. Another important factor that I want to mention here is the role of emotion in our daily communication. Research shows that emotion help us to understand the intentions of others and facilitate the communication and interaction between people. Based on this important characteristics about emotion, it's so clear that why emotion is in a hot spot, and there are lots of activities in academic and industry around of these topics. So let's have a look about how industry domain take advantage from emotions recognition system. I put some examples here, but if you search on the web, you can find several ideas and workaround how we can apply or use emotion recognition to on the other domain. So the domains that I investigated here is robotic, augmented and virtual reality, education, and road safety. Let's talk about robotic first. Robotic robots and autonomous system are new member of or are the new member of our society in near future. Robots are designed and developed to help people and have a collaboration with them. So here, understanding a human correctly is the most important part or point for robots to get the right services. There is a domain which is called human-computer interactions that tries and do lots of researchers to address these questions or problem. And based on the result and direction from this domain, emotion plays a crucial role in this interaction. Augmented and virtual reality is another domain that can take advantage from emotion recognition. This means that augmented and virtual reality or video games are designed to give a view of new real world and or virtual world with an overlay of computer generated information. So one of the important factor here is that what is the feeling or what is the thought or idea of the user when they interact with that environment. Let's give you an example. For example, we have a jewelry company that they set a new service on their website, which is called virtual appointment. And in that appointment, customers, instead of going to the store and try jewelry, they can use their web and connect it to the website and use their augmented reality system to try the jewelry. So here, it's important that when the user try the jewelry, what is their feeling? By capturing their feeling, we can provide very valuable feedbacks for that company, that how the user's feedback or feeling is about their products, and give a better direction to them to become more productive. The other domains which can take advantage of emotion is education. We know that education is we know that emotion is very important in education system and can affect learning process. So this means that by monitoring a student emotion, we can have this idea that how their learning process is going. And this is the method that is now actively researched and used in the classroom and or e-learning classes. And at the end, let's talk about road safety. Cars company nowadays provide some sort of advanced system that can help driver to drive safely and decrease the risk of crash. One of these systems which is very important is a system that can detect some sort of negative emotion like as fatigue or anger. Why? Because the research shows that this negative emotion can increase the risk of crash, and working on this sort of system is really beneficial that can help driver to cope with their negative emotion and also increase the risk of crash. So there are theories that explain and define emotion. Here I put some 12 the famous of these theories, which are discrete and dimensional theory. In the discrete theory, we classify the emotion into 7 basic categories, which are happy, sad, neutral, surprise, fear, disgust, and anger. These basic emotions are inherent to human brain and are universally accepted. On the other side, we got dimensional theory, that in the dimensional theory, we map emotion based on the 2D vector, which is called arousal and valence. And what is valence? Valence describes the extent to which an emotion is positive or negative. And it ranges from unpleasant, which is here, to pleasant, which is the other side of this vector. So unpleasant is the most negative part of the valence vector, and pleasant is the most positive part of the valence vector. We got arousal, and arousal describes the intensity of the perceived emotion. And it ranges from the activation, which is the most negative part of the arousal vector, to activation, which is most positive. For example, let's look at the happy. Happy got the highest or most positive pleasant, and not very high or low arousal. So based on this mapping, you can find the emotion where they are in this 2D vector. So monitoring emotional well-being is a fundamental to physical and mental health. Feeling positive emotion in time improve physical and mental health. On the other side, chronic negative emotion can cause depression and anxiety and affect physical health as well. Therefore, monitoring emotion is an effective way to predict our mental health. Here I put the most important emotion modalities that can be used to detect emotion. We got 2 sides, physiological signal and physical signal. Physiological signals are coming from inside the body and they are not observable. This emotion, the source of this physiological signals could be brain, heart, galvanic skin response, respiration, and body temperature. On the other side, we've got physical signals that they are playing important role for detection of emotion, and our feelings can affect our speech, or can change our facial expression, or in a way that we are writing. It is important to know that although physiological signals are reliable modalities to detect emotion, but users need to wear these sensors, which cause difficulty for data collection in real time. Therefore, instead of this modality, physical signals also provide a reliable solution for emotion detection with contactless and not expensive method to collect the data. And from these physical signals, we should mention that facial expression is the most reliable physical signals to detect emotion, and we want to talk about this modality and how we can use it to build a emotion recognition model in this presentation. So facial expression, if we consider facial expression as the modality that we want to detect emotion, it should be mentioned that facial expression changes in different emotions. So we have different facial expression based on our emotion, and this change is a result of contraction and relaxation of some facial muscles. In addition, the research shows that verbal component convey 1/3 of human emotion, but non-verbal components convey 2/3 of human emotion. This means that when we look at the facial expression, we can get more information about emotion than when we listen to the speech. And as I mentioned, collecting facial expression can be done using contactless and not expensive method. So now we talk about how we can recognize emotion using machine learning and deep learning techniques. So here I put an architecture about how we can build a model that is started from image capturing, and then when we collecting some images, we need to do some pre-processing, like as noise filtering to apply on the images. And because we want to use facial expression, first of all, the face region should be segmented on that images, and then from that part, we need to extract some landmark or facial components from the face. And at the end, when we got that landmark or facial component, we can extract some sort of high-level features from that point. And after we extracted the features, we can pass them to the classifier to do the classification. So this is the general overview about emotion recognition model that wants to be built using machine learning or deep learning techniques. So there are two approaches, machine learning that I call them as a traditional approach. In that approach, as I said, we got input images and then we pass them to the face detector, and then we extract the landmark. We have some handcrafted features. Handcrafted features means that the features that is designed or found by doing research and human expert offers them how to extract by providing some sort of formula or functions about how we can extract them, and at the end we can pass them to classical classifier such as support vector machine to do the classification. This is the traditional approach. On the other side, we got deep learning approach that is more advanced than machine learning approach and got a better performance. So in that case, instead of we extract handcrafted feature and do the pre-processing, we can pass the raw data to a group of layers, group of deep learning layers in a deep neural network. And for example, convolutional neural network is one of the examples here that we can use to extract the features and do the classification. So in this deep neural network, we got several layers, and in each layer, we're extracting some sort of feature. So these layers can be divided into convolution and pooling, and in the convolution, we are extracting new feature, and in the pooling, we selected the most important features from the extracted feature in the previous layer. And do it iteratively, this network can extract several variable and high-level feature, and then it can be passed to the dense layer to do the classification using softmax. And I should mention that several AI companies now are working on sort of models, deep learning model that can detect emotion. Microsoft, Azure, Amazon, and Google are some of these examples that they provide Face API, and from that Face API, you can they extract emotions from the face. It is important that thanks to these APIs, end user without having pre-knowledge about computer vision or machine learning or deep learning can just use this method and then extract emotions. Okay, now I'm talking about Azure Emotion Recognition API. So here I put the Azure Emotion API, and the first part is that which sort of features that this API extracted. I found this image from the web that shows that which face landmark should be used for are used by Azure to extract the features from face related to emotions. And as I mentioned, Azure used deep learning approach to do the feature extraction and classification. We've done one case study using a small face data set and using Microsoft Azure to see that how Microsoft Azure performance to detect that 7 basic emotions. And we got the performance here, which is anger, disgust, fear, happiness, neutral, sadness, and surprise. You see happiness got the highest performance and the fear got the lowest, but the rest of the emotions, which is sadness, neutral, and surprise, got the high performance, and disgust and anger also got an acceptable performance. Therefore, based on our observation, which is done on a small face data set, we understood that this tool could be used in our mental health product to help us to understand the user mental health. So here I should also mention about some sort of challenges that every face detector and emotion recognition system should face when they are working with a different data or pictures. These challenges could be rotation, partial phase, brightness, blur, and noise. And what is our observation about using Azure for the rotation? And also I have read some sort of articles that also confirm our observation. For rotation, the result shows that Azure is sensitive to the rotation over than 30 degrees. For partial phase, this is the filter, or this is the problem that Azure is so sensitive to that one, partial phase. And if you pass some sort of images that they don't have mouth or eyes, the performance of the model decrease significantly. And it is natural. It's natural because as I showed that Azure extract the emotions from that landmark. So face and eyes plays an important role for extracting the feature related to emotion. Then we got brightness. For the brightness, Azure performs acceptable, and in the high brightness or darkness, the performance goes down. But for the rest, low and medium, the performance of the model was fine. For blur and noise, the performance of the Azure was really good, especially in noise, because we passed a high level of noise to the model, and then by that noise also model was performing well to detect emotion. Here at the end, I want to mention about our product and how we use for integrated Azure Emotion API in our mental health product. So we were talking about in our mobile app, we can collect different information from the user. Some of these emotions could be the online surveys or ambient parameters that we can ask user to answer them using chatbot or other methods. And also for the ambient parameter, I could mention that there are some sort of information on the internet, or we can use from the cameras and sensor to collect, and then we can integrate it by Azure Emotion API. So Azure Emotion API applied on our mental health application to detect emotions that is collected by camera in real time. And then all this information are collected and sent to a function, and that function map them onto the 2D vector, which is arousal and valence. And at the end, after when we did the annotation, we build up a machine learning model as well to see that what is the link between the collected information that is annotated by Azure Emotion API and that function which I mentioned to mental disorders such as depression, anxiety, and stress. And so in the Azure ML Studio, we built the machine learning model, deep learning model that do this classification or prediction, do this classification to see how we can predict the risk of mental disorder. So thank you. These are my information about my email and LinkedIn, that if you have any question or if you want to connect me, you can you can use them. And please let me know that you are audience from this webinar. So I'm happy if I can help you. If you have any question, I can help you. May, it's done from my side.
All right. Thank you, Dr. Naim. Thank you, Dr. Ben.
Thank you.
Okay, seriously, guys, that was really interesting. Thank you, and I hope our viewers learned as much as I did. Okay, so we received a number of questions from our audience during the discussion. I would like to ask you, Dr. Ben, Dr. Naim, to answer them. Are you ready?
Yeah.
All right. So the first question is for Dr. Ben. Dr. Ben, it's from Hilda. Hilda asks, you said to choose the app we use. How do we choose them and how do we know if they're legit?
Okay, there's two resources I use personally. One of them is Beacon and the other one is Head to Health. I will share my screen so I can show them the website.
Sure, go ahead.
Yeah. There you go. So the Beacon is actually came up after the concern about if the apps are legit or not, and it's like a quality control kind of hub. So you can go and type whatever you like here, any type of app, the name of the app or name of the services, or you can go and look for an app based on the category. Like, let's say depression, you can go and check depression and it will tell you all the apps in here. And you can see in the category in the right here, it tells you if the app is actually, reviewed or not. Like, for example, that one, you see, and it has all these reviewers about the app from negative to positive. And the other one is Hit to Health. If you're in Australia, you can use Hit to Health. You can look for services, anything you like. And also they have a chatbot that will guide you through your journey. Third resources is Google Scholar. You can type the name of the app. You're probably going to find an art like a study about it or something like this. Go to the website, Google it. Explore the website, see who's behind it, and that's all.
All right. Dr. Ben, these are free for registration, right? These app checkers?
Both of them, they're for public. They're for free. You can use them for free. Beacon is actually provided by the Australian National University, and Hit to Health is by the Australian government.
Okay. But Dr. Ben, these are all from Australia. We have viewers from Malaysia, Singapore, I think from the Philippines. Would these be applicable to them?
Yes, Beacon will be available for them. Beacon,
right.
They can log in and register, and they can go through every single app listed in there. Because all the apps there is not only for Australia, it's also international. It tells you if the app from Australia, like the origin of the company.
Oh, that's great. That's great. Thank you, Dr. Ben.
No problem.
Now for Dr. Naim. Dr. Naim, DLA wants to know, what about in the case where emotional expressions differ from person to person? How does AI come into that?
So when we are talking about building a model and then we are collecting data, yes, we have this problem that maybe data are subjective and maybe emotion is different in different culture. But based on the models that I explained, which is Azure, they build because our focus was about using Azure Face Emotion Recognition API, and this model are tested on different people from different culture and big group of people. So this increased the chance that we got a generalized model. But if you want to build some sort of model from scratch, and that is the point that you need to collect several lots of images, and which you should have the gender equality, culture, and also your participant should be selected from different culture and countries to be sure that you got a generalized model. And also keep in mind that basic emotions are universally accepted, which means that for happy, sad, angry, and that emotion which I mentioned, there is the same definition in different countries. So if you are work with a basic emotion, you may have not that problem much, because at least all of us know that what is the meaning of the anger and how we should express it.
Okay. Thank you, Dr. Naim. Another question from Anonymous. How are the use cases developments of facial recognition affected by the pandemic, and how face coverings are required for the foreseeable future? Oh, okay. So it's very timely now in the pandemic. He asks, what is the effect of that during the pandemic now that there are face coverings are required?
So is that for, this is
For
the question for me, or?
For you,
like
Dr. Naim, I think,
okay.
yes.
So my if there is a point, if someone wants to do to build a model or use this model, the current API models during the pandemic, there is because many people wear masks, so maybe this API using just facial expression API alone would not be a good idea, because as I mentioned, we need to extract some landmark from the face first and mask some parts, so then we have the problem of partial face, and then therefore the API may not work very well. So it's better that in that case we fuse or integrated facial or emotion recognition API with other modalities, and then like as physiological ones which I mentioned, or voice or a speech to get a better result. So the point is that monitoring speech plus, for example, facial expression to detect better.
To the anonymous, yeah, Naim is the brain behind all this AI in Australia and behind the human interaction with technology. I've got a question back to you, Mr. Anonymous or Mrs. Anonymous. Would you recognize someone's facial expression while they're wearing a mask? Will you know if they're happy? Will you know if they're sad? If they're just covering the mouth? Of course not. You'll probably maybe say, oh, they're smiling. They're not smiling, they're probably sad. So if the AI does not, if you as a human cannot recognize if the person is happy or not, AI won't.
Oh, that's interesting. Okay, Anonymous, I hope that answers your question. Next one for Dr. Ben. Dr. Ben, this is from Mimi. Mimi asks, you experimented with Siri on mental questions, right? I think you mentioned this before on your talk. You experimented with Siri, with Cortana, and then with some other AI question bots. What are the common mental questions asked? Do you know that, Dr. Ben?
Okay, so for Mimi, first of all, I'm not a Siri person. I'm a Google person.
Oh.
Second, I didn't do any statistic about who's behind. It was like the most common questions, but I would assume it's like normal questions. Is mental health exist? What is the symptoms of this? Let's say, will depression have cure? Is there a cure for anxiety? I think this is the most common questions that probably will ask online.
Makes sense.
Maybe this days the question will be when this pandemic will end. I think this is the most question will be asked these days.
I think so too, Dr. Ben. Okay, last question. Sorry, we have a few more questions, but we're going to the last. The question is for Dr. Naim. Dr. Naim, what is the scope of detecting emotions using speech, such as the tone, shrillness, speech? Are those considered, or are there other emotions considered if you're detecting emotions using speech, if and when, for example, this pandemic, we can't see the eyes, we can't see the mouth, we can see the facial features, we're relying on speech. What are the scopes of detecting the emotions?
So if I got it correctly, the question is about how we can detect emotion using a speech instead of facial expression, isn't it?
Yes.
So for a speech, we have the same, as I was talking about the machine learning or deep learning approach to build a model to detect emotion using face. So let's say that we want to got that model by using speech instead. So for that case, also we need to collect the sort of speech samples. Then we are in the that part should be converted to text, or to extract some important information using NLP, natural language processing, from the text, or from the tones of voice or a speech, we can extract some important features, and then we can map them to the user's emotion. So building the model, the process of building a model will be the same as the first slide which I showed as an architecture. That means that we need to extract extract some features, but not from voice, and in two ways. One way is that we convert voice to text, and then using NLP, natural language processing, extract that feature, and the other way is that we extract some important features from the tones of the voice, the features behind that voice. And then based on that features, then we can do the classification using machine learning or deep learning.
All right, thank you very much, Dr. Naim.
Can I add something?
Yes.
Voice recognition also is very important at the moment, and the big vendor like us, Microsoft also works on voice and or when you convert voice to text to do the sentiment analysis. So if someone likes to get more information, they can send me some email and I can share with them good links that help them or get them direction how we can do it.
All right, thanks, Dr. Naim. Okay, so guys, if you have more questions for Dr. Ben or Dr. Naim, we'll send you an email and then you can reply back, or we'll send you their emails, if that's all right, Dr. Ben, Dr. Naim, if they have questions, pertinent questions on mental health, Azure AI using mental health, for use mental health, they can give it to you?
LinkedIn is better for me.
LinkedIn, okay. So we'll give you guys Dr. Ben's LinkedIn and Dr. Naim's LinkedIn as well, so that you can reach out to them if you have questions. We're down to our last stretch, Dr. Ben, Dr. Naim. Any last words for our audience who may want to start a career in digital mental health, or any parting words for them? Dr. Ben, Dr. Naim?
Again?
Anything you want to say to our viewers? Any last words if they want to start their careers in mental health, digital mental health using AI?
I will start from my part or where I'm specializing. You can't develop things until you understand it. You don't have to study it. So if you want to do digital mental health, I would recommend you, like if you want to do AI in mental health, I would recommend you first to understand how humans behave. Probably Psych 101 online, a couple of courses, to be exposed to different schools of psychology and different approaches of how to measure them, and different treatment tools like CBT, ACT, and so on. Then you can go to the data and the machine learning after that.
All right, thanks, Dr. Ben. Dr. Naim, any last words for our viewers? Dr. Naim?
Yeah, thanks to Dr. Ben. I think that answer to this question got several, because this question got several aspects. So Dr. Ben address to part of them, but I think that from technical view, if someone wants to work on a smart model that that can detect or recognize some sort of mental state and then use them in the recommendation system, I think it depends that what is their background. If you are coming from the you have this background that you work with the AI before and you can do everything by coding. So the recommendation is that you can work on some sort of smart model, but because for example, emotion recognition API that is presented by Azure is a key tool for most of the people who doesn't have background in AI, or and then they want to build up something on top of AI. So I recommend the user to review cognitive services in Azure to see more about to see that how Azure works with images, voice, text, and then do the analysis to extract emotion. And also there is a tool that Dr. Ben mentioned about it. That tool was Louise, language understanding model. That model provides the sentiment analysis for text. So I would like to encourage the audience to read more about Louise as well, because when you are working with Louise and you pass a text to Louise, Louise can tell you about what is the emotion behind.
All right. Once again, thank you, Dr. Ben. Thank you, Dr. Naim, for joining us this um, Tuesday morning, afternoon, evening, depending on where you are in the world. Thank you for joining us, Dr. Ben, Dr. Naim. We hope to see you again in our next webinars, guys. Thank you.
Hopefully.
Thank you.
Thank you so much.
Thank you.
Okay, for
Bye.
our viewers, you may want to start your career in data analysis or in digital mental health. What is a good way to start that career? You may be wondering how you would be starting that. With us today is CloudSwyft founder and CEO Dan Angelo de Guzman to share with us the details of the first ever micro-credential of CloudSwyft, produced together with Microsoft and Future Learn, entitled Artificial Intelligence on Microsoft Azure, Machine Learning, and Python Basics. Dan will share with us what we can learn in that micro-credential and how it can help us. Dan?
Hello, everybody. I guess it's good morning to the Southeast Asian countries and good afternoon to Australia. First of all, thank you, Dr. Naim and Dr. Ben, for that fantastic webinar. And indeed, artificial intelligence has been around across different industries, from healthcare to manufacturing to semiconductor to retail. And now specifically on the healthcare itself, the most interesting topic that is being discussed nowadays, which is mental health, which is most of the time one of the most I think in Southeast Asian countries underserved industries that there's a lot of opportunities on in terms of psychological effects of what's happening in our daily lives, and how we can apply technology to understand better human interaction, as well as the psychology, the science and the psychological aspect behind it. So thanks everyone for joining this webinar. So again, we would like to emphasize the global micro-credential spotlight here. So Dr. Naim and Dr. Ben mentioned about different technologies and different tools that you can play around with and you can research about or you can learn from, like machine learning models, Azure Cognitive Services, Louise chatbots, integrations, coding on Python programming that will, mostly being used or vastly being used in different artificial intelligence. So all of these topics, Azure Cognitive Services, from the basics of using Azure Cloud to navigate through all these tools in Azure Cognitive Services, how to configure and build Louise chatbot integrations, all the way up to essential maths of machine learning and artificial intelligence. All of that has been co-created and co-offered by CloudSwyft together with Microsoft and FutureLearn. And all you have to do is to check this link out, as what May has been rendering here on the screen. You can go to that link, bit.ly/AI microcred. Again, bit.ly/AI microcred, and you would be able to access the program and have a look at what's inside, the content available. And the very first round that we're going to have is going to be on September 28, 2020. For those of you who are interested in getting into the program, let me just try to share my screen so I can okay, there you go. So for all of the attendees of this webinar, for the artificial intelligence and Microsoft Azure machine learning and Python basics, all of you can get 10% discount. All you have to do is to write an email to futurelearnsales@cloudswift.com. Again, you can send an email to futurelearnsales@cloudswift.com in order for you to claim your 10% discount into this micro-credential, which will start as its very first run on September 25, 2020. So in a world of pandemic today, where we would be experiencing a lot of challenges that is in effect of this pandemic, All we have to do is to find ways on how we can be more productive. And I think learning and education has been at the forefront of that movement. And one of the ways to upskill and try to be productive in learning is to have a look at a micro credential that can help you jumpstart or kickstart some skills and to learn some tools and technologies that can help you land a career in the industries that utilizes artificial intelligence, machine learning, and data science. So thank you so much again, everybody, and have a fantastic day ahead. All right, so there's another activity that, if you may, you guys, if you would like to go to bit.ly/15 September survey, go to that link and you would be able to address and you would be able to answer our survey. So if you could be kind enough to fulfill our survey so that we can deliver and sponsor you better webinars moving forward, and how we can improve the programs, and what are the topics and ideas and suggestions that you have in mind in the next weeks and the next months or so that we are planning along. Please do so. So again, if you're interested in answering our CloudSwyft webinar survey, just go to bit.ly/15 sept SEPT survey, and then you can go ahead and answer our webinar survey. Again, thank you so much for your time, everybody, and have a great day. May?